Okay, we're on page 2 of our chapter 7 notes, example number 10. We're asked to simplify this. If I look at this, we have a quotient raised to an exponent of -3. Now there are many different ways you can go about approaching this problem. One way could be you could take care of the negative exponent and invert the fraction, and then you would have your fraction raised to the +3, and then continue simplifying. The approach that I would start with is to look at what's inside the parentheses and simplify what's inside the parentheses. Let's take care of some of these negative exponents first. This z to the -1, if I want that as a positive exponent, I would bring it down to the denominator. And the x to the -1 that's in the denominator, I'd bring that up to the numerator, so it would then have a positive exponent. So we would have 4x to the 4th, y squared. Now the z to the -1 has been pushed down into the denominator, and the x to the -1 has come up as an x to the +1, over 2 y to the 7th, z to the 1st, raised to the -3 power. Still working in parentheses here, we can reduce some things, right? The 4 and the 2 reduces to 2 and 1. I have an x to the 4th and an x to the 1st. When multiplied in the numerator would be an x to the 5th. I'll bring the 2 over at the same time. And my y's here, the y to the 2nd and y to the 7th, they can reduce, leaving me with a y to the 5th in the denominator. And then the z in the denominator is still there. So now this has been simplified, but we still have to raise it to the -3 power. Well, take care of the negative part of the exponent by taking the fraction and flipping it, inverting it. So this would be y to the 5th z over 2x to the 5th raised to the +3. And now the last thing to do is to distribute, right? You're going to distribute the 3 into both the numerator and denominator and end up with y to the 5th raised to the 3rd power. You multiply those exponents, and that's going to equal y to the 15th, z to the 3rd, over 2 to the 3rd is 8, x to the 5th raised to the 3rd, 5 times 3 is 15. So that's y to the 15th, z to the 3rd, over 8x to the 15th. Number 11. Again here, looking here, we've got a lot of negative exponents. We have this -5a to the -2b to the 1st c divided by 25, all raised to the -2. So again, there's many different ways that you can approach this. If you wanted, you could distribute the -2 in. You could take care of the negative portion of the exponent of -2 by inverting the fraction. All right. I'm going to work inside the parentheses first again, and going to take again some of these negative exponents, making them positive by bringing them down into the denominator. Sorry about that. So we'll have -5, just c would remain in the numerator there, and then 25, a to the second, b to the first, all raised to the -2. Now, the only thing that reduces is the 5 and 25, right? So let's reduce that. Now, take care of the negative exponent by inverting the fraction. So we have 5a squared b over -c raised to the +2. Now distribute. 5 squared is 25. A to the second raised to the second. You multiply those exponents, that's going to be a to the fourth. B to the first raised to the second is b to the second. And -c raised to the second is +c squared. So that's been simplified. Our next group of problems, we have some multiplication here. And in number 1, we have this 4x to the third times y divided by xy squared times x divided by 12y. Right? If I look at the numerators here, this is all multiplication in the denominator. So let's divide out common factors. All right? Think about dividing out common factors. And by that, we mean factors that are common to a numerator and denominator. In no particular order, but I like to follow, I would probably first look at the coefficients, the numbers 4 and 12, right? 4 goes into 12 3 times. Then I would stay alphabetical. That's just my habit. This x to the third and that x, that would reduce, or better yet, these two x's would divide right out. And the y in the numerator there and this y in the denominator there would divide right out. So it looks like I'm left with x to the third over y squared times 3, which I'll write as 3y squared. Next, number 2. Again, there's different ways you can approach this problem, right? I can start off by taking the 8 and the 12 and reducing that, dividing each by 4. And now that this was brought down to a 3, then I could take this 3 and divide it out with the 3 in the numerator. And the 2 and the 6 would reduce. we have this y to the negative 3 in the denominator, y in the denominator, and y to the negative 4 in the numerator. If you don't like the negatives here, then just do that. Get rid of the y to the negative 3 in the denominator by pushing it up into the numerator with a positive exponent of 3 and bringing the 1 in the numerator down to the denominator, giving it a y to the positive 4. So what do we have here? I would have y to the positive 3 over, I have this number 3, and this y to the negative 4 has been pushed down to y to the positive 4 times y. This y to the third can divide out with y to the fourth, leaving you with a y. So we're left with 1 over 3y squared. Number 3 here. We have this y to the 10th over 2x to the third times 20x to the 14th y to the negative 6 over x. Multiplication, again, let's divide out common factors. I'll start with the coefficients. 2 goes into 20 10 times. The variables, my x's, have an x to the third and an x to the first in the denominator. So that would be actually x to the fourth, and x to the fourth would reduce with x to the 14th. All right, x to the fourth reduces with x to the 14th, leaving you with x to the 10th, because 14 minus 4 would give you 10 in the numerator. And then for my y's, I have y to the 10th times a y to the negative 6 in the numerator. When I'm multiplying, the rule is to add the exponents, so that would equal y to the fourth. So I have 10 x to the 10th, y to the fourth. But again, there are many different approaches to this. There are other ways of doing that that are correct. Last example here on the bottom of page 2. We have 7x to the negative 3 raised to the second times x to the fifth times x. Well, let's just distribute this. 7 raised to the second would be 49. X to the negative 3 raised to the second would be x to the negative 6. And x to the fifth times x to the first would be x to the sixth. So this is 49. X to the negative 6 times x to the positive 6 is going to be x to the 0. And remember, anything raised to the 0 power is 1. So this is 49 times 1, which is 49. Continuing on to page 3 of the notes. More examples here of simplifying. The directions for 1 and 2 say to write the expression without a denominator. Okay, so if we don't want a denominator, then let me get a to the fourth that's in the denominator. Let me bring it up to the numerator. So this would be 4a to the second b times a to the negative 4. Now, our like variable bases of a here, a squared times a to the negative 4. We're going to add those exponents, and we'll get 4a to the negative 2b. Number 2. Same thing. I don't want a denominator, so this a to the negative 4, let's bring it up in the numerator. For a squared b, a to the positive 4. Well, a squared times a to the fourth is a to the 6. So this would be 4a to the 6b. The next group, the next 4, you want to write the expression using only positive exponents. So I want only positive exponents. So I'm going to get rid of anything that's negative. So the 3x to the negative 3 over y to the third, take the x to the negative 3, put it down in the denominator. So I have 3 over x to the positive 3, y to the third. That's our end result. Number 4. Again, I want to write only using positive exponents. So I'm going to start by taking anything with a negative exponent, rewriting it so that it has a positive exponent. So this is 5x squared y. This x to the negative 3 has been brought up to be an x to the positive 3 in the numerator, over y to the 6, z to the positive 6. Now, if there's any reducing that I can do, I would do that, but there isn't. There's no dividing out common factors, but there is, we do have to multiply x squared times x to the third and get x to the fifth. So 5x to the fifth. Oh, I misspoke. I hope some of you caught me. The y and y to the sixth, they can reduce. This y would divide out with one of those, leaving a y to the fifth in the denominator. So y to the fifth, z to the sixth. Next, number 5. We got a lot of negative exponents here. Okay. Well, before we start moving things around, c to the negative 7 divided by c to the negative 7. Anything divided by itself is going to equal 1. So let's just cross those right off at the start here. And now let's move around the remaining negative exponents. So I have 4 b, and then b to the third has moved up, over 2a to the third, and that a to the negative 2 has moved down to be an a to the positive 2. The 4 and the 2 reduce. I could have done that in the beginning as well. b to the first times b to the third is b to the fourth, and a to the third times a to the second is a to the fifth. And number 6. Again, we want only positive exponents. And notice here that the 30 and the negative 15, they can reduce. We can switch these, or I'm almost thinking about trying a different method, and that is actually subtracting. Okay. I have negative 2. I'm putting the negative up there instead of down in the denominator. X to the negative 5 divided by x to the negative 2 is going to be negative 5 minus negative 2, which would be negative 3. And then y to the 5th divided by y to the 3rd would be y to the 2nd. Now one more move. Cannot keep that, so we bring that down into the denominator. So negative 2 y to the 2nd over x to the positive 3. That was only one way. Again, there are other approaches to this. In 7, 8, and 9, in this section, we want to describe the mistake. Right? Negative 2 raised to the 2nd times negative 2 raised to the 3rd should be negative 2 raised to the 5th. Right? Same bases, you just copy the base and then apply the rules for the exponent. Number 8, x to the 8th divided by x to the 2nd. When you're dividing, what do you do with the exponents? You subtract the exponents. So this should be x to the 6th, not x to the 4th. And number 9, x to the 4th times x to the 3rd should be x to the 4 plus 3, which is x to the 7th. Okay, and finally, our last section of this, page 3 of the notes. Evaluate each function for the given value. Don't use a calculator. We have f of x equals x to the negative 3 times x to the negative 1. We want to evaluate f of 2. Well, we know we would go and replace our x's with 2. Before we do that, we could simplify this first if we wanted. That's one approach. F of x equals, what's x to the negative 3 times x to the negative 1? It would be x to the negative 3 plus negative 1, or x to the negative 4. And now we could put in 2. So f of 2 would equal 2 to the negative 4, which is 1 over 2 to the positive 4, which is 1/16. Or we could have put in 2 first, 2 to the negative 3 times 2 to the negative 1, and worked it out that way. Next example, number 2. We have f of x equals 2 times 2/3 raised to the negative x plus 4 times 2/3 raised to the negative x. And we want to evaluate f of 1. Okay, well, there's no combining that we can do right here. So let's go ahead and substitute 1 in for x. So we have 2 times 2/3 raised to the negative 1 plus 4 times 2/3 raised to the negative 1. All right, well, an exponent of negative 1, that means all we do is we invert the fraction. So we have 2 times 3 over 2 plus 4 times 3 over 2. Now, actually do the multiplication. Remember, this would be 2 over 1 times 3/2, which would be, those 2's would actually reduce, divide out, so that would be 3 plus, that'd be 4 over 1 times 3/2, and I know how much you guys love fractions, so bear with me here. 4 and 2 would reduce, and we're left with 2 times 3, which is 6. So 3 plus 6, we get an answer of 9. Number 3, we have f of x equals 3x to the negative 2 plus 6x to the negative 2. We can't do any combining there at all. And then the whole thing raised to the third. And we want to evaluate f of negative 3. So let's go to our function, replace our x's with negative 3. This is a toughie, all right? Negative 3 raised to the power of negative 2. That's going to be 1 over negative 3 to the positive 2 plus 6 times negative 3 raised to the negative 2 is that 1 over negative 3 to the positive 2. Okay, 1 over negative 3 squared. Negative 3 squared is 9. So this is 3 times 1/9 plus, again, our 1 over negative 3 squared. Negative 3 squared is 9. 6 times 1/9. This whole thing is in parentheses, and we still have to raise it to the power of 3. 3 times 1/9, 3 into 9, 3 times, so that's 1/3 plus 6 times 1/9. I forgot my parenthesis there, sorry. 6 going to go into 9, that's going to be 2/3. Oh, and isn't that nice? What's 1/3 plus 2/3? 1/3 plus 2/3 is 1, or 3/3, which is 1. And then 1 raised to the third power is 1. And lastly, we have f of x equals 2x to the 0 plus x to the negative 2 divided by x to the negative 1. We want to evaluate f of 2. Well, one thing I would take care of, and that is x to the 0. Anything to the 0 power is 1. Right? So we could take care of that right away. But suppose you didn't see that. we'll go through, we'll make our substitutions. So f of 2 equals 2 times 2 to the 0 plus 2 to the negative 2 over 2 to the negative 1. Well, 2 to the 0, that is 1. So that's 2 times 1, which is 2, plus 2 to the negative 2, I could write as 1 over 2 to the positive 2, over 2 to the negative 1 is 1 over 2 to the positive 1. Now, why can't I just kind of try like dividing these out? I can't, because there's a plus sign there. Okay? It was multiplication, then I could start reducing, but there's a plus sign there. Okay, so again, you've got to love these fractions. Numerator's 2 plus, well, 2 squared is 4, so that's 1/4 over 1/2. There's a couple ways we can go from here. Okay, I could see this as a complex fraction, right? And if it's a complex fraction, why not multiply everything by the least common denominator of all the fractions, right? Which would be 4. Our LCD would equal 4. So if I multiply everything by 4, that'll clear out some of our fractions. So 4 times 2 is 8, plus 1/4 times 4 is 1, and 1/2 times 4 is 2. 9 over 2. And we're done for today.